Hello everyone, welcome to my course Introduction to Market Structures. So, we were doing dynamic games, that is extensive games. So, today we will conclude that portion. So, we have already done what is information set. Information set is a collection of decision nodes of a player, and it can be singleton set or it may have many decision nodes. If it has many decision nodes, that is more than one decision node, then the player does not know in which decision node he is taking the decision. So, he only knows that in which node, in which information set it belongs to, but it does not know exactly which node it is in. Okay. So, to make, so if suppose a player is already, they have played a game like this, suppose they have already played a game of this nature. This is player 1 L R, and this is player 2, this is L dash R dash, L dash R dash, and then suppose again player 3. Okay. So, this is player 3, player 3, 3, 3. Now, suppose I have a situation like this, okay, and here I have some payoffs I will not specify now. Now, here player 3, in this situation player 3 is, when it is moving, it does not know whether it is in this node or in this node or this node, because player 3 has not observed these movements of or these actions of player 1 and player 2. So, that is why it is imperfect information, but it is complete information because all the payoffs are known. Okay. So, here what is happening in this situation, player 3 does not know which node it is, but suppose we have a situation where it is L double dash, R double dash, L double dash, R double dash, L double dash, R double dash, but it has one more strategy, and that is suppose U, one more action, that is U, and this has one more action, and that is suppose D dash. So, then see, each node has a different sets of action. In this node it has L double dash, R double dash. In this node it has L double dash, R double dash, and U dash. In this node it has L double dash, R double dash, and D dash. So, if player 1 has chosen this action and player 2 has chosen this action, then the game is here, and player 3 has not observed this action. But if player 3 only can choose from these two actions, from these two, only from these two actions it has to choose, then it knows it is in this node. So, for this reason what happens, that all the action set must be same in an information set. So, in an information set, the set of actions must be same. Okay. Otherwise, the player 1, it will no more be an imperfect information, because player 3, even though it has not observed the actions, but from the set from which it has to choose an action, it can decipher or it can infer what are the past actions. Okay. So, that is why the action must be, set of action must be same. Okay. And then we have also defined what is subgame. Subgame, it begins from any node which is other than the first node, and subgame, it follows all the decision nodes from any specific decision node, that is includes all decision and terminal nodes following n in the game tree, and does not cut any information set. So, if a whole information set should belong to only one subgame. A information set cannot be partitioned into two different subgames. Okay? So, this is. Now, we will discuss some solution concept. So, we have done backward induction. Backward induction is a method of solving the EA, but what solution, while using backward induction, what we were doing? We were moving from the last subgame to, and then we have moved backward, and we have tried to find the Nash equilibrium at each stage. Okay? So, a specific solution concept for this type of dynamic game is subgame perfect Nash equilibrium, and this was proposed by Selton. Okay. So, it says a Nash equilibrium, it is a Nash equilibrium is subgame perfect if player strategies constitute a Nash equilibrium in every subgame. So, let us take in every subgame. So, let us take an example. Okay. Player 1, its action is L and R. Player 2, its action is L dash, R dash, L dash, R dash. Player 2, so it is a complete information game. Okay? Complete information and also perfect. Okay, this is subgame. Now, here it has two subgames. This is starting from this decision node, we have this as one subgame and this is another subgame. Okay. So, in this subgame, so how do we solve? We use the backward induction only, but here we specify that it has to be a Nash equilibrium in each subgame. So, it is a Nash equilibrium in this subgame, it has to be a Nash equilibrium in this subgame and also in the whole game. Okay. So, this, if player 2 is here, then we know it is optimal to choose this R dash because 2 is greater. So, in this game, this is the action that player 2 is going to choose. In this game, when player 2 is choosing, it is again going to choose this. 3 is greater than 2, here 2 is greater than, right. And then, so this game now it is what? So, player 1, since we are using backward induction, so it knows that if it chooses L, player 2 is in this node and player 2 is going to choose R. And if player 1 chooses R, player 2 is going to be in this node and it is going to choose R. So, player 1 knows this by player 1 can infer this based on this game because it is a information is complete. So, player 1 what it will do? It will compare these two payoffs. So, for player 1 it is going to be like so, player 1 is going to choose this action. So, it is going to be this here. So, in this game subgame perfect Nash equilibrium is in this game it is this and in this game it is this and then it is chooses this one. So, this, but while we were doing backward induction outcome and we were trying to find the optimal outcome in the backward induction in the same game, it is here, it is this, here it is this and then from this it is here. So, we do not need to, because we do not need to specify this. So, backward induction outcome is only this. But subgame perfect Nash equilibrium outcome is this: we have to specify the Nash equilibrium in each subgame. In backward induction outcome we do not need to. So, this is the difference. So, it is a complete profile of this, all this here has to be provided. Okay. So, let us do another example. Suppose player 1, player 2, again player 1. Okay. This is L, R, L dash, R dash, L double dash, R double dash. Payoffs are so the subgames are, this is one subgame, this is another subgame. Okay. Now, here we have to find the Nash. In this subgame, player 1 is always going to choose this. So, player 2, it has this, if it chooses L dash 1, and if it chooses R dash, it will, player 1 is going to choose L dash, so it is going to get 0. So, player 2 chooses this, and player 1, if it chooses L, it is going to get 2. If it chooses R, then it is going, player 2 is going to choose L dash, so it is going to get 1. So, it is going to choose this. So, this is the subgame perfect Nash equilibrium outcome. So, in this starting the games, this is the initial node, the action is this, in this action is this, in this action is this one. Okay. Let us take another example. So, this example is slightly big game. It is played between 3 players. It is U, D, it is again U, D, it is again U, D, okay. Suppose this is the game tree. There are 3 players and game tree is of this nature. So, the subgames are, it has many subgames. This is one subgame, this is another subgame, this is another subgame, and this whole is also a subgame. So, it has 1, 2, 3, 4 subgame in this whole games. Okay. So, let us start from this. In this game, player 2, it will compare 1 and 3. So, player 1 is always going to choose T here. In this subgame we know. Then let us start from this subgame. This game, player 3, D dash, U dash. If D dash gives 0, U dash gives 6. So, player 3 is going to choose this. In this subgame, player 3 is choosing between D dash, U dash, D dash 3, U dash 1. So, it is, and here this, now you can see that this game has become something like this. So, player 2 is compared 2 and 3. So, player 2 is going to choose this, and here this is going to be and this is 4 3 3. So, player 1 is going to choose this. So, in the whole game you can look at it in this way, it is this and it is this. So, in this subgame the subgames are Nash equilibrium sub this and here it is this, in this it is this. So, then finally, so subgames are represented by this green lines in this game tree. Okay. Here again by the green lines in this game tree. Okay. Now, we are going to define what is a strategy. We have talked the actions here. In this game, what is the action? In this game, subgame, what is the action? In this subgame, what are the actions, like that. Now, we will specify strategies. What is a strategy of a player? Strategy for a player is a complete plan of action. It specifies a feasible action for the player in every contingency in which the player has to move. Okay. So, keep this in mind, in every contingency in which the player has to move. Okay. So, now let us define it for a very simple game. Okay. So, let us take this initial game U D U dash D dash U dash D dash. Okay. Let us take this game. We have solved this game. We know what is the subgame perfect Nash equilibrium of this game, right. Now, player 2 is taking decision in two contingency. It has two contingency, in this node and this node. So, contingency means mainly in how many nodes it is taking a decision. It is not, or you can say in how many information set. Okay. Best is going to be one information set implies one contingency. For player 1, it is one only, it is one decision. So, the set of actions, so for player 1, set of action or the strategy sets are same and it is U and D. Okay. But for player 2, it has two. So, let us name this, this is 1 dash and this is 2 dash. These are the name of, or you can say, sorry, this is 3 dash. Okay. So, these are the name of the nodes. So, its contingency is 2 dash and 3 dash. Okay. So, how do we have to define the complete plan of action. So, we will suppose strategy 1 of, these are for player 2. Okay. Strategy 1. So, if player 1 plays U, then you specify U dash, and if player 1 plays D, then U dash. So, this is U dash U dash. This you can say it is one strategy of player 1, because it has two contingencies or it has two information set in which it is going to take the decision. So, it is u dash, here also it is taking u dash and here also it is taking u dash. So, this is suppose strategy 1. Then we can specify strategy 2, second strategy. Second strategy is, if player 1 plays u, then play u dash, and if player 1 plays d, play d dash. So, this is u dash d dash strategy. This is strategy 2. This is for node 1 or node 2 dash, this is for node 3 dash. Third strategy, if player 1 plays u, then play d dash, and if player 1 plays d, then play u dash. So, this is d dash u dash strategy. This is the third strategy. And we have a fourth strategy, and that is, if player 1 plays u, then play d dash, and if player 1 plays d, then play d dash. So, it is d dash d dash strategy. So, the whole strategy set of player 2, you can say it is u dash u dash, u dash d dash, d dash u dash, d dash d dash. So, we have 4 strategies. So, it is here it will play this one strategy, this the second strategy, this and this third strategy, this and this, it is going to be the fourth strategy. Okay. So, these are the strategies, but for player 1 it is only this. Now, so this is the way we are going to define the strategies. Now, once we know the strategies, so then we can specify this dynamic game as a normal form or a static game, and there how do we do? I will show you just now, and then we know if we have a static game or a normal form game, then we know the how to find the Nash equilibrium, and then from all the set of Nash equilibrium of that game, how to find the subgame perfect Nash equilibrium? Only those which do not have any credible trait. If there are some credible trait, then it is subgame perfect Nash equilibrium, and if a Nash equilibrium and there are some actions which are not credible enough, then we say it is not subgame perfect Nash equilibrium. So, it is a Nash equilibrium, but it is not a subgame perfect. So, I will discuss that now. Okay. So, let us take this game. So, this game, if you look at this game, what are the player 1 u d, player 2 u dash d dash u dash d dash 3 1 2 2 3 2 4 3. Set of strategies for player 1, it is u and d. Set of strategies for player 2, it is u dash u dash, u dash d dash, d dash u dash, d dash d dash, right. Now, normal form game can be u dash u dash, u dash d dash, d dash d dash d dash. This is for player 2. U and this is for player 1. Okay. Now, if it is player 1 has suppose played U, so here and it is, so this payoff in this block it is going to be 3 1, and here it is going to play this and this, but player 1 has played this, so it is going to be 3 2. Okay. Player 1 is playing U and it is choosing U dash. Okay. And here when player 2 is choosing D, it is doing D dash. So, it is when player 1 is playing U, it is choosing D. When player 1 is choosing U, it is choosing D dash. So, it is again here player 1 is choosing D and it is choosing U dash. Here it is choosing D dash. So, this is how we will get the payoff matrix of a normal form game. And in this normal form game, if you want to find the pure strategy Nash equilibrium, what are this pure strategy? If it plays U, so player 2 is indifferent between these two strategies, and if it plays this, player 1 is going to follow this. So, this is not a Nash equilibrium, right. But if it plays again this, player 1 is going to choose this. So, again this is not a Nash equilibrium. But if player 1 chooses D, player 2 is indifferent between this and this. And here if player 2 chooses this, it is going. So, this is one Nash equilibrium. It is a weak Nash equilibrium, pure strategy, weak pure strategy, but it is a Nash. Here again, if player 2 chooses this, player 1 is going to choose D, and if it chooses D, it is indifferent. So, this is again a Nash equilibrium. So, the pure strategy Nash equilibrium are D and U dash D dash, and again D and D dash D dash, right. Yes. Now, these are, we have two pure strategy Nash equilibrium. Now, we have to find out which is subgame perfect. If you look at this here, we know here it is going to choose this, and here it is going to choose this, and player 2 1 finally chooses this. So, D dash D dash, D dash D dash. So, this is subgame perfect Nash equilibrium. This is not a subgame perfect. Why? Because see what it is saying. If player 1 plays U, this is U dash D dash. If player 1 plays U, if it is in this node, then player 2 is going to choose this, and because of that, because it is giving a trait that if you choose this, I will choose U dash. So, better choose this, then I am going to choose this. But then player 1 knows this, that if player 1 chooses this, when player 2 is here, it is never going to choose this. Instead, it is always going to choose D dash, because this is 2 is greater than 1. So, that is why this strategy u dash in node 1, node 2 dash and first node here and d dash in the second node of player 2. So, this and this, it is not credible. This is credible, but this is not. So, that is why this is not a subgame perfectness. But this, it is always going to choose this here in this subgame and this in this subgame. So, that is why this is a subgame. So, we have a Nash equilibrium in each subgame here in these strategies. But here this u dash is not a subgame if we take this. Okay. So, now let us do another example. Okay. So, okay. So, this game has this as one subgame, this is another subgame. Okay. Now, here player 2 has only one information set. So, suppose these nodes are 1 dash, 2 dash, 3 dash and player 2's information set is only this 2 dash, but player 1's information set, it has 2 information set, that is 1 and 3 dash this. So, it has 2 contingencies, player 2 has only one contingency. So, the actions strategy set of player 2 is L dash and R dash is this. But for player 1 it is this L and next it is L dash, then again L and R dash, this is for the second contingency. We have to discuss all the possible plan, right. So, we have to specify the actions for each nodes or each information set. R L dash, R R dash. But here if player 1 plays L, then it is never going to choose this here because the game ends here, but still we have to specify it. So, these are the strategies of player 1 and these are the strategies of player 2. So, the normal form game, it is for player 1, this is player 2 L dash R dash, this is L double dash L R double dash R double dash it is this. Now, if player 1 plays L, player 2 does not get any chance to play, the game ends here. So, this for this thing, if player 1, so this is for player 1, if it plays L, it is going to be 2-0. It is going to be 2-0 because since it has played L, so player 2 it is same. So, for all these contingencies we get the same payoffs. Okay. But suppose player 1 has played R and player 2 has played L dash, then it is going to be this one 1 1 and here player 2 is not getting any chance, it is because player 1 is playing R. So, the game has moved to the second node and player 2 is making a decision, that is L dash. So, the game ends here. So, that is why the payoff here in this case it is also going to be 1 1, and then we will get this. Okay. Now, here if you look at this game and you have to find out, suppose the pure strategy Nash equilibrium, then if player 2 plays this strategy L dash, player 1 is indifferent between these two. If it plays this, he is indifferent. So, this is one Nash equilibrium, and here if it plays this, he is indifferent, and if it plays this, he is indifferent between these two. So, this is also a Nash equilibrium. These are weak Nash equilibrium. If it plays this, player 1 moves here. If it plays this, it will, player 2 is going to switch here. So, this is not a Nash. Again, this is not a Nash equilibrium. If it plays this, player 2 is going to choose this, but if it choose R dash, player 1 is going to choose R L double dash. So, this is, so these are the two pure strategy Nash equilibrium. Out of this, we have to find the subgame, which is subgame. So, okay, sorry, this is double dash, okay, otherwise it will be confusing, right. Make it double dash. So, this in this A it is this, here it is, if we plug in this value here, it is 3 0. So, player 2 is going to choose here, it is 1 1. So, player 1 is, so these are the, we have already shown the subgame Nash equilibrium of each subgames. So, here it is going to choose, in this here it is going to choose this L double dash, not L R double dash. So, that is why this is not a Nash equilibrium, this is a Nash equilibrium. This is a Nash equilibrium, but this is not a subgame perfect Nash equilibrium. So, this is, you can say as P and E, subgame perfect Nash equilibrium. This is not, because here L double dash is not credible enough. If you play this strategy and player 2 plays this strategy, sorry, if you play this action, player 2 plays this action, I will be here, player 1 is going to be again here, then it is not going to play this, because this is not credible, this there it is going to, because 3 is always greater than 0. So, that is why in this strategy L double dash, it is credible, but L R double dash, it is not credible. So, in that sense it is a subgame perfect Nash equilibrium. Now, we have already done or discussed about perfect information case. Now, we will do imperfect information. Now, the solution concept, we will again use the backward induction, that is, we will start from the lowest or the last subgame and then we will move backward, and the solution concept is same as subgame perfect Nash equilibrium or as P and E. Let us do some example to understand this. So, it is again a 2-player game, and suppose it is player 1, it is A, it is B, again player 1, okay. L R. So, this game, this player 2 is not going to observe the action of player this one, and also it is not going to observe this. Okay, all this is not known. Player 2, when it is moving, it will know that player 1 has chosen B, otherwise it will not get the chance to move at all. Okay. So, in that sense player 2 knows that player 1 has chosen this, but player 2 is not going to observe the action of this action L, and similarly player 1 is not going to observe the action of R. Okay. So, now how do we solve this? So, we will start with this subgame. Okay. So, this subgame is, you can think this subgame as a simultaneous move game, or you can say a normal game, where since this is the information set of player 2 and it has 2 nodes, so it is not sure. So, action set is same here. So, the here strategy set of player 2 is simply LR. Strategy set of player 1 in this subgame is again L and R. So, this game can be represented as a normal form game, and it is in this way. This is for player 1, this is for player 2, actions L and R. So, player 1 L, player 2 L, L L, this combination 1 2, L, that is L, and then R, this is R 1 1, this R R, then player 2 L, R L, R R R R. So, this is the normal form game. Okay. Now, so we play this game and we find the Nash equilibrium of this game. So, in this the Nash equilibrium is, so it is obvious that for player 2 L is a dominant strategy, or R is dominated by L. So, it is going to be chosen this, and so player 1 will choose this. So, this is a Nash equilibrium. So, here in this game the player 1's action or A, so the Nash equilibrium is R L. Okay. Then what do we do? Again for player 1 A B, so it is 3 0 and this is 2 3. So, player 1 is going to choose this. So, here you can represent the Nash R and L, this. Okay. But how do we specify the strategies of players? These strategies are for only this subgame. For the whole game, the strategies are like this. For player 2, it is strategy set is same. It has only one information set here, and then it has 2 nodes in it and they have same A. So, it is L and R. But for player 1, it is taking decision at 2 nodes here and here, right. So, it is going to be A L, A R, B L, B R. This is the strategy set of player 2. Okay, whole game. Now, we can also represent this game as a normal form game, and because we know the strategies. So, you can say this is L and this is R, A L, A R, B L, B R, right, A L, A R. If it plays A, then it is game ends here. So, in all these A, so the payoff is same. It does not matter, player 2 does not get any chance, or player 1 does not get the second chance. second move. Here it is B and then player 1 is choosing L and then again L. So, this. So, now here we will place this game here, payoffs here. So, it is 1 2 okay. Now, we can find all the Nash equilibrium of this game. What are the Nash equilibrium? If it plays L, it can choose this or this indifferent between, but it will be here it is going to be indifferent between this. So, this is a Nash equilibrium, again these are the Nash equilibrium. So, you can say all these are Nash equilibrium, but are all of them subgame perfect? Because here if you look at this game, it is LR. So, it is LR only this, because LL, LL, LL it is not, it is dominated by, if you play this, by this, right, this. So, R. Now, so that is why in this subgame, the Nash equilibrium of this subgame is not part of this strategy profile. Here again this is LR, this is LR, this is also not a here. So, this is all, that is why this is not a subgame, but this is RL, RL, RL. So, in this subgame it is a Nash equilibrium is L R L. So, this is subgame, this is R R, this R R, it is not a Nash equilibrium in this subgame. So, that is why only this is S P and E, but in this normal form game we have 4 pure strategy Nash equilibrium this. Let us do another example, and this is going to be our last example, and with this we will end the game theory portion and start industrial organization. Okay. Suppose it is this. Okay. So, imperfect game between player 2 and 3. A B, A B, C D, E F, E F, 3 0 4, 1 1 1, 3 0 4. Okay. This is 1 1 6. This is 1 0 8. This is 0 2 0. This is 3 2 1. this is 0 0 1, again this, suppose this payoff here is 2 1 2, payoff here is 6 3 1, payoff here is 3 0 2, here is 2 2 3. So, in this game, if you look at the subgame, one subgame is starting from here, another subgame is starting from here, and this whole another subgame is this. Okay, so it has 3 subgames. So, let us first solve this subgame. This is between player 2 and player 3. Now, this is an imperfect because player 3 does not know that it is what is the action chosen by the player 2. Okay. So, we can it is C, D and G, H. G, H. Payoffs are C, G, C, G. So, it is 2, 2, 3. Then it is 3, 0, 2. It is 6, 3, 1. 2 1 2. Okay. So, it is played between player 3 and player 2. And the payoffs are, we have to compare 2 3, this 0 2 3 1 1 2. So, here if player 3 plays 2 plays C, player 3 is going to play H, 3 is greater than A, and if player 3 plays G, it is going to play D because 3 is greater than 2, and if it plays this, it is going to choose this one because 2 is greater than 1, and if it plays H, it is going to choose D because 1 is greater than A. So, because D is actually a dominant strategy for player 2 here, if you look at this, C is dominated by D. So, in this way, the Nash equilibrium is DH. So, in this subgame, Nash equilibrium is DH. Now, let us look at this subgame. This is played between player 1 and player 2. Player 2 is E, F. Player 1, it is C, D. Okay, and the payoffs are you can look at the payoffs from here, it will be like this, and here if you play player 1 plays C, player 2 is going to play F because 1 is greater than 0. Player, if it plays F, player 1 is going to be indifferent between these two, but if it plays D, player 2 is going to play E, and when it plays E, it is going to, so this is a Nash equilibrium. It is a weak Nash, sorry. This is a pure strategy Nash equilibrium in this case. Now, from this we can get, so the first this game becomes, here for this payoff is 2 1 2, right, D and H, D and H, and then here for player 2 if it plays so here the outcome is CF. So, this is 1 1 1. and rest we know. So, we now play this subgame, play this subgame. So, here again we have two players, player 2 and player 3, player 3 A, B, player 2 it is E and F. So, if it plays A, E and A, so it is 1, 1, 1, E and B, so it is 0, 2, 0, E, F, and it is A, 3, 2, 1, 0, 0, 1. So, we have to compare the last two digits. So, for player 2, if it plays E, best response for player 3 is to A, because 1 is greater than 0. If it plays A, player 2 is going to choose F, because 2 is greater than 2. If it plays here F, it is indifferent, okay, between 1 and 1. But if it plays this, player 2 is going to choose E, not this. So, this is a Nash equilibrium. So, here Nash equilibrium is F and A. Okay. So, this game now A, B, A is 2, 1, 2, and this is 3, 2, 1. So, player 1 is going to choose this. So, in this game, if we want to find the path which shows the game this, and then it is C and F, and here it is D and H, D and H, it is D and H, and then finally here it is F and A, it is F and A. So, we get the subgames in this way. In this subgame, this is the Nash equilibrium. In this subgame, this is the Nash equilibrium. Then in this Nash subgame, this is and this are the Nash equilibrium. So, finally this. So, but here if we try to present this game as a normal form game, then it will take a huge space. So, we will not do that. Instead, we will simply specify the strategies of each player. Suppose strategies of the whole game of each player. Player 1 has two nodes, right, this and this. So, its action set is, or its AD, AD, BC, BT, right. Two contingency for player 2 strategy. It is taking a decision here, it is taking a decision here, and it is taking a decision here. Here its information set is singleton, this is again singleton, but this is not a singleton. So, its strategy profile, it has 3 nodes or 3 different information sets. So, 3 contingencies. So, these are the complete set of action plan that player 2 can have. For player 3, we have 2 A, one is here and another is here. So, for player 3 it is GA, GB, HA, HB. So, from this we know what is going to be the SP and E from this A. It is BC for player 1, DFF, HA. So, this is actually subgame perfect. Why BC? Because player 1, when it is choosing here B and here it is choosing C. For player 2, you see in this it is choosing D here, it is choosing E here and it is choosing F here. So, it is D, F and F. DFF. So, this is this one DFF. Then here it is HA for player 3. Player 3 here it is choosing H and here it is choosing A. So, this is the subgame perfect Nash equilibrium. Okay. So, thank you very much, and this is the from where you can read this portion. Okay. Chapter 2 of Gibbons and chapter 9 of search and where. Okay. So, these are the specific page numbers, you can look at it. Thank you again.